Welcome to Study Loop.
All right, we're now in chapter 13 on problem 2, and we're looking at the first part of the problem here, which is which atom of water is associated with the cation, and explain. So over here we have our water drawn out, and we notice that water is a polar molecule, and the negative ends is right here. The negative dipole is with oxygen, and the positive dipole is with the hydrogen. Cations are always positive. They're one of our metals, and ion means that it's by itself. So the cation will always be attracted to the negative pole of water, and there will be an electrostatic attraction between the two. So the answer for us is that it's oxygen. Looking at the second part of the problem, let's see what we have. Which of the following explanations accounts for the fact that the ion-solvent interaction is greater with lithium than with potassium? So if we look at the periodic table, we notice that both of the lithium and potassiums have a +1 charge because they're both alkaline earth metals and they're in that first row. But when we notice is lithium is much higher. It is going to be in the second row, whereas potassium is going to be in the fourth row. And we're going to keep that in mind as we go through these questions. So lithium is of a lower mass than potassium. That's absolutely correct, but mass has nothing to do with how an electrostatic attraction is formed. So that answer is completely incorrect. B, the ionization energy of lithium is higher than that of potassium. Because it's already a cation in water, we don't care what the ionization energy is, because ionization energy means what is the energy that you get from breaking apart lithium or potassium. So that's definitely not our answer. And now we look at the third one. Lithium has a smaller ionic radius than potassium. And that's going to help us out here with this electrostatic interaction, because this oxygen has to get to lithium. Lithium having a smaller radius means that the hydrogen aren't going to interfere with it. It's not going to have an interaction of a positive nature. It's going to be just more accessible than its potassium counterpart, which is going to be much larger. So that's absolutely correct. C is the right answer. So let's look at D and E and see why they're not correct. Lithium has a lower density than potassium. Density has nothing to do with electrostatic interactions, so we know that's not our right answer. And lithium reacts with water more slowly than potassium. If we look back into that section, we'll notice that that's absolutely untrue. Lithium reacts faster than potassium. So there we are, we have our answer. Lithium has a smaller ionic radius than potassium.